This is a lecture on dilutions. Dilution is a process where one takes a concentrated solution of a known concentration, and by adding more solvent like water, one can prepare a diluted solution of a specific concentration. Units for concentration can be of any of these units: 1 molarity, 2 mass percent, 3 volume percent, and 4 mass volume percent. In making a diluted solution, the number of moles of solid will be the same in both the concentrated and diluted solution. The equation for dilution is C1 times V1 equals C2 times V2. If C is in units of molarity or mole per L, and V is in units of L or liters, then molarity times volume of the concentrated solution equals molarity times volume of the diluted solution. In the end, moles of the concentrated solution equals moles of the diluted solution. Problem 1 is, a stock solution has a mass percent concentration of 10%. 50 ml of this solution was used to make 200 ml of an unknown concentration. What is the mass percent of this diluted solution? It is given that C1 equals 10%. V1 is 50 ml and V2 is 200 ml. One needs to find C2. The solution is by using the dilution equation and plugging in all the numbers. C2 equals 2.50%. Problem 2 is a stock solution of KNO3 has a concentration of 0.25 m. What volume of dilute KNO3, whose molarity is 0.10 m, can be formed from 80 ml of concentrated solution? It is given that C1 is 0.25 m, C2 is 0.10 m, and V1 is 80 ml. One needs to find V2. The solution is by using the dilution equation and plugging in all the numbers. V2 equals 2.0 times 10 to the 2 ml. Problem 3 is, what volume of water is needed to add to 2 liters of 1.75 m K2CrO4 to make a 0.100 m K2CrO4? It is given that C1 is 1.75 m, C2 is 0.100 m, and V1 is 2L. One needs to find V2 and eventually the volume of water. The solution is by first using the dilution equation and plugging in all the numbers. V2 equals 35L. To solve for the volume of H2O, or water, volume of the diluted solution equals the volume of the stock solution plus the volume of water. After plugging in all the numbers, the volume of water is 33L. An alternative approach in solving for the volume of water is to substitute V2 for V1 plus water. After plugging in the values and solving for V water, it does equal 33L. Here are some review exercises for you to work on. Solve each of the following problems. 1. A sample of 7 ml of concentrated sulfuric acid, H2SO4, is used to make 250 ml of a 0.50 m H2SO4 solution. What was the initial concentration of the sulfuric acid? 2. A hydrochloric acid solution, HCl, has a concentration of 12.1 m. A 41.2 ml sample is used to make a more dilute solution. If the new solution has a concentration of 0.400 m, determine the volume of the solution. 3. 30 ml of water is added to 20 ml of 0.0500 m Na2CO3. What is the new molarity of the sodium carbonate solution? For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.